Preparing for a Google ML interview? Here are the top 25 questions you must know for 2026. I'm your guide through this essential preparation, covering updated trends like multimodal models and efficient training. These questions are crucial for understanding the core principles and cutting-edge advancements in machine learning. First, what is machine learning? It's a subset of AI, distinct from deep learning, focusing on systems that learn from data. It encompasses supervised, unsupervised, and reinforcement learning paradigms, each with unique applications. Next, explain overfitting and underfitting. Overfitting occurs when a model learns noise, while underfitting means it hasn't learned enough from the training data. Solutions include regularization, dropout, and early stopping to improve generalization. What is the bias-variance trade-off? It's the balance between a model's tendency to make errors due to overly simplistic assumptions versus its sensitivity to small fluctuations in the training data. Discuss gradient descent variance. Batch gradient descent uses the entire dataset, stochastic uses one sample, and mini-batch uses a small subset. ADAM is an adaptive optimization algorithm that combines the benefits of RM-SPROP and AdaGrad. Evaluation metrics are key. For classification, we use accuracy, precision, recall, F1, score, AUC, and ROC curves. For regression, common metrics include mean squared error and mean absolute error. Explain cross-validation types, specifically k-fold. It partitions data into k subsets, training on k, 1, and validating on the remaining fold. Feature engineering and scaling are vital. Normalization scales values to a range, while standardization transforms them to have zero mean and unit variance. PCA, or Principal Component Analysis, is used for dimensionality reduction by transforming data into a new set of uncorrelated variables. Ensemble methods combine multiple models to improve predictive performance. Bagging, like random forests, trains models independently. Boosting, such as XGBoost, trains models sequentially, with each new model correcting errors of the previous ones. SVM basics involve finding the optimal hyperplane that best separates data points, and the kernel trick allows for nonlinear separation in higher dimensions. Decision trees classify data by splitting it based on feature values, and pruning helps prevent overfitting. Neural network basics involve layers of interconnected nodes, using activation functions to introduce nonlinearity and backpropagation for training. CNNs are specialized for image data, using convolutional layers to extract features and pooling layers to reduce dimensionality. RNNs, LSTMs, and GRUs are designed for sequential data, with LSTMs and GRUs addressing the vanishing gradient problem in RNNs. Transformers, with their attention mechanism, have revolutionized sequence modeling by allowing parallel processing of input sequences. Transfer learning involves reusing a pre-trained model on a new, related task, saving significant training time and resources. GANs, or generative adversarial networks, consist of a generator and a discriminator that compete to create realistic data. Reinforcement learning involves an agent learning to make decisions in an environment to maximize a reward, using methods like Q-learning and policy gradients. How do you handle imbalanced data? Techniques include SMOTE for oversampling minority classes and undersampling majority classes. Hyperparameter tuning optimizes model performance. Methods include grid search, random search, and Bayesian optimization. Explainable AI, or XAI, helps us understand model predictions using tools like SHAP and LIME. Federated learning allows models to train on decentralized data sources without sharing raw data, ensuring privacy. Model deployment involves putting models into production using tools like Docker and Kubernetes for serving. Ethical AI considerations are paramount, addressing fairness, accountability, and transparency in AI systems. Finally, recent trends include efficient models like Mixture of Experts and the rise of multimodal large language models. To ace your interview, recap these top takeaways. Practice coding on platforms like LeetCode and conduct mock interviews. Mastering these concepts will set you apart. Remember, consistent practice is your best ally. Subscribe for more insights and good luck on your Google ML interview.